Hi, in this video we are going to solve one of the UG Senate 2024 previous year question. So it is related to the transistor, that is BJT, and as per the UG Senate syllabus it is the third unit or else the fourth one, analog electronics related unit, so which includes analog electronics and some kind of third unit, that is network analysis related concepts, also required to solve this type of question. And before going to the detailed solution regarding this question, so if you guys are preparing for the net or select or set for the electronic science, then I am providing the 1000 previous year questions course. Okay, so which will cover the conceptual concept related to the particular question whatever we are discussing, so that this course will really helpful to you to crack the UGC NET JRF or else the set examination. But because the previous year questions related topics, okay, is very much important, okay, to know how much width and depth we have to prepare for the examination. So if you guys are preparing, seriously preparing for this type of examinations, okay, and if you want to crack, then here I am providing the WhatsApp number for this one, so for this course. So if you're interested, then just express your interest, okay, to this provided WhatsApp number. Fine. And let's go back to the question. So here in this question they are asking to find out the operating point of the given transistor. So if you want to find out the operating point, it means that we need to find out the VCE, that is the voltage across the collector and emitter, as well as the collector current, that is IC. So we have to find out both these two. Fine. So IC means here the amount of current flowing through this one. So if we can able to find out, then automatically our question will be solved. So let's start here. So let's take, it is a current IB which is flowing from through this path to the base, okay, and in this branch, so whatever the branch I am showing here, so follow this branch. So in this branch the starting voltage is VCC, that is 10 volts, and the ending voltage is a VBE, well, that is from base to emitter, that is 0.7 volts is given here. And in this path the resistance provided is 500 kilo ohm. So while coming to the base current, whatever the direction I provided, so IB can be taken as a starting voltage minus ending voltage, that is VBE, divided by the resistance in that path. So let's take the resistance as a VB. Okay, so now, so resistance I am taking as an RB. Okay, so now coming to this one, a VCC is given as a 10 volts in the question itself, and coming to the VB is given as 0.7. So 10 minus 0.7 divided by, and the resistance in that path is 500 kilo ohms. So if I calculate this one, then I will get 9.3 divided by 500 kilo. Okay, so it is the base current what we are going to get. Fine. So once after getting the base current, now as I told that if you want to find out the operating point, we need to focus on IC as well as the VC, right? So after getting the IB expression here, now if you want to find out the collector current, as we know the regular expression, that is IC is equal to beta into IB, right? So beta in the question itself they given as a 100, so I'm taking beta as a 100 here. So let's take beta as 100 into base current as I got as 9.3 divided by 500k, right? So now let's start the cancellation here, this 100 and in this 100, so both these two gets cancelled. Now I will get 9.3 divided by 5 into 10 power minus 3. Okay, so if I calculate this one, then I will get as 5 ones, okay, then 5 eights, something into 10 power minus 3. So on the whole, it can be taken as a approximately 1.8 milliamperes. So I got IC as a 1.8 milliamperes, right? So if you go to the question without wasting the time, here IC, in all the four options IC are different, not the same. So without wasting the time, you can directly opt the option 4 as a correct answer. No need to go for the calculation of VCE. In case in the two options, that means in any one of the option here, if here also if they given as IC as 1.86 milliamperes, then we need to focus on the VCE, right? Okay, so let's start calculating the VC here. So how to find out the VC? Let's have a look. Yeah. So if you check this path starting from here to here, okay, I will get VCC is equal to, that means VCC is equal to, if I take the current flowing this one as IC, then I will get IC into RC, that is voltage drop across this resistance, that is IC into RC, and from here to here voltage drop. From here to here voltage drop means it is a collector terminal and it is a emitter terminal. So I can take this one as a VCE, right? Okay, now as I told that if you want to find out the operating point, we need to focus on VC, right? Okay, here VC is there. So now from this expression, VCE can be taken as a VCC minus IC into RC. That is equal to VCC is 10 minus IC. As I got IC here as approximately 1.8 milliamperes, right? So let's take 1.8 milliamperes into RC. They given as 2 kilo ohms. So that is equal to 10 minus milli and K, both these two gets cancelled. So 1.8 into 2 can be taken as 3.6, and then it will be how much it will be? Something around 6, right? Okay, 6.4 something I will get. But if you take the exact figure here, then you will get the exact value. So here we will get as a 6.28 volts. Fine. Okay. So it is how we have to calculate the operating point of the given transistor. Right? So if you want to get little bit more additional knowledge regarding this operating point and all, then let's have a look. Basically, operating point means if you take the VCE and IC, okay, VC and IC, both these two graph, the graph between the voltage across the collector emitter and the collector current, and we can take the load line. Of course, I'm not going into the in-depth how to take the load line and all. So let's take the DC load line. Okay, it is the DC load line, and each and every transistor will be having its VA characteristics, right? So if you take the characteristics as like this, now the intersection point of the DC load line as well as the VA characteristics of the transistor. So it is the intersection point, right? So this intersection point can be taken as an operating point. Okay, so it can be considered as an operating point. In depth and all, we'll see. Okay, anyhow, it is a basic concept related to the operating point. And if you are coming to the power amplifier concept and all, then here if the operating point is exactly at the midpoint of the DC load line, okay, then it is called as a class A amplifier. If it is below the midpoint, if it is above the midpoint, then the types of the power amplifiers will vary. Okay, and if the operating point is exactly at the midpoint of the DC load line, okay, exactly midpoint of the DC load line, then it can be taken as here one point and here one point. Okay, now whatever the signal, if it is the input signal we are giving to the power amplifier, then we are going to get the 100% amplification for this complete signal. Okay, we will get as like this. The complete signal will get the amplification. If we are shifting the operating point, then your amplification part of the input signal will changes. Okay. Anyhow, that's a power amplifier concept. That's a different one. But anyhow, it is a way of solving this question and some basic concept related to the operating point, DC load line and VA characteristics. Okay, so have a look at this one and just subscribe this channel if you are preparing for the NET or the SET related or else in some kind of electronics related examination. Okay, so if you are preparing seriously for this examinations, then you may register for this course. Okay, but before registration, you just WhatsApp me your interest to this provided contact number. Okay, so that I will guide you how to register for the course and all. Okay, Thank you very much for watching this video and prepare well for your examination and all the best.